All right, so this video is just a quick follow-up of one of my previous videos where we were looking at trying to load in a really large file into C#, and obviously when we don't have enough RAM to be able to hold the entire contents of something that's, multiple gigabytes up to beyond terabytes, how do we go and do that? So in that past video, which I'll link, I'll put a card up here somewhere, go watch that and then come back to here if you haven't seen it already. But in that video I was talking about the implementation that I had to try and segment that data, and I had something functional, and then I had this point as I was recording and kind of showing it like, I know that this isn't going to be optimal, but it's working right now. So in this video, I'm going to jump over to the code, we're going to look at a little optimization I made, and if you stay right to the end of this video, I will link the follow-up to this one, which is yet another optimization that I'm super excited about that has some benchmarks. But yeah, let's go jump over to the code and I'll show you what I did. All right, so here in Visual Studio, I have my segmented stream class, and where I was calling out in the previous video where I was going to observe some potential performance implications, like I had observed that it was slower, almost twice as slow as a normal stream. I had figured that it had something to do with my read method in particular that I'm overriding. And specifically, I saw this bit of code here. I almost jumped right to the juicy part there. But this bit of code here, that if we read what it's doing, I was like, this has to be the thing that's going super slow. So let's just walk through from a few lines above to see what's going on, and just to kind of explain a little bit, this method, as we're iterating through, we're trying to take the current location within the stream, go look up a segment. So this again is a segmented stream. I have a bunch of chunks in memory representing the underlying portions of the file, and a caching mechanism for that so that you can seek around and it will keep a cache of the most recently used pieces. So as we navigate through this and we are streaming the data, this method will go look up the segment and then asks that segment for the sequence, which is going to be the array that is holding the data that it represents from disk. So nothing too fancy here. And then my goal was that I wanted to start using like things like spans and read-only sequences. These are things that in my experience in C# I haven't had a ton of exposure to, and I'm really excited to try learning about them and using them more. So I said, okay, I'm going to expose this sequence here. So if we look at the type of sequence, it's a read-only sequence of bytes. And then I said, great, now that we have that sequence, depending on where we're reading, we actually don't need to start necessarily at the beginning of the segment. We might be partway through that segment. So if your segment was, say, 4K or 4 megabytes, whatever, if you're reading the 100th byte, you're starting at the 100th byte into that sequence, or into that segment, sorry, then we can actually slice that sequence up. And what's cool about this is the slice method here is not like a copy where you're just copying the bytes out and putting them into another array. Kind of like how substring works for strings. You're not actually just making a copy of those bytes into another array. We're just getting a view of that data from, this range here, from the segment offset, and then the length of the slice. So we get this view. We haven't actually copied more data going from line 67 to 68, so that's awesome. Then we put this reader around this, and what I was doing is actually using this reader and then saying, while the reader can read, get this next byte, add it to the buffer, and keep moving. And if you're familiar with reading data, even if it's actually in an array and you're just copying, when you do stuff one byte at a time, it is going to be way slower than other methods that we have. So I wasn't exactly sure what tools I had access to be able to make this better, but I figured this is going to be crappy, but it's working. Let's look at what I did. I'll just go ahead and delete this code. Boop. So what I was able to do is go get the buffer, and this buffer is what we're going to be writing our data into. And then I have it as a span. So again, just like when we're slicing, we just have this new view over this buffer that's from the offset we want to write into, right? So buffer and offset, I'm just going to scroll up a little bit more. Buffer and offset are passed in to the stream read method. So we get the buffer And we're going to basically just use the length of the slice that we want to write to. So now destination span is exactly the length that and location that we want to be able to copy to. The sequence reader actually has this method, try copy to, that will go read from where it currently is around this subsequence and try to copy that data so that it fits this destination span. And what's cool about that is instead of doing one single byte at a time in a while loop, I'm able to use all of the optimized code that they have in .NET behind try copy to do the entire length of this span. This alone put me right at par with reading between a normal stream and my segmented stream. I'm not going to show benchmarks for it. You can maybe take my word for it. It was slightly slower, like maybe a couple of percent, like less than 5%. But this change between what I had on screen and right here is actually enough to make that difference of being twice as slow to that other margin of error. So again, just to repeat, it went from doing one byte at a time copying into the array to this actual reader try copy to and doing the entire span. So that's awesome. Now, when I went to go implement this whole thing, and this is going to kind of tie into the follow-up video that I'm going to link you to at the end of this, I know that the concept that we just kind of talked about there of being able to have these read-only views of the data and trying to avoid copies, this is really how we're getting a lot of performance squeezed out of the stuff that we're looking at. When we look at the actual API for streams, something about that doesn't sit well with me. And the whole idea about what doesn't sit well with me is that this read method literally requires that we pass in a buffer of bytes, and that when we read, we have to do a copy. This means that if we're trying to look through a data set, again, if we're streaming across that data, the API that we're given requires, right here, requires that we give it a byte array and that we have to start copying things around. Yes, of course, you can just use the seek method and seek to the location you want, but if you're just trying to read through things and scan across it, the stream API must force you to copy bytes into the buffer. This part really bothers me, and especially for my use case when I'm trying to go across a lot of data really quickly, I don't want to have to copy anything that I don't need to. So I'll leave it there as a little bit of a spoiler for what's coming up, but just to reflect on what we looked at here, basically we were able to squeeze out way more performance just by avoiding single byte copies, which I knew was going to be bad in the first place, to a different API that lets us copy the whole buffer at a time. So thanks for watching. If you stay and watch this video right here, this will show you the benchmarks for the other optimization that I think is way better than using streams.